Yeah, good evening to Varandal. So today
Good evening, sir.
we'll discuss a topic that is a time series. So previous class we discussed about what is in the time series and what are the components of time series. But we left one thing, that is a last one, the random variations or random components. So once we'll go through that, what are the components are there once again. So briefly. So as you know that what is in this time series? See, time series is a sequence of observations on a variable made at a regular point or intervals of a time, so which are arranged in the chronological order. So as I told you that when you collect information with regard to particular variable, so if you arrange the data in a sequence, whatever you are taking some observations, if you arrange the sequence order, for example, if you collect information about blood pressure in the morning time at 9 o'clock, so what the doctor will, they will take collect once the information about the patient at 10 o'clock and 11 o'clock. So they will arrange the data with a chronological order: 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, like this. So if you collect information with regard to a particular variable, so in the sequential order, that is called time series. So generally, we can say the time series is nothing but the time series is the data which is collected at a over a period of time. For example, whatever the data is there, if you collect a data from over a period of time, that is called time series data. So that is a numerical data which is arranged over a period of time. That is over time. So the time series may be second wise, minute wise, hour wise. Okay. So day wise, weekly, okay, weekly, monthly, quarterly, half yearly, yearly, once in 5 years, and once in 10 years. So these are the data which we'll collect from different sources of information, different sources. So, for example, prices about if you collect information with regard to the tomatoes, vegetable prices, or fruits prices day by day or day to day, you will collect the production and GDP. You will collect information through quarterly and yearly. So these are the types of time series data. For example, year wise, the production in terms of tons. This is also stock prices hour wise. So these are sales year wise. For example, if you take into account the two-wheeler vehicles or four-wheeler vehicles, or how much sales in a particular year. So you will take like this in 2001, this much of sales, in 2002, this much of sales. You consider this a time series data. So as you know that cross-section data, nothing but cross-section data is the data which is collected at a point of time. Nothing but, for example, if you want to conduct a survey in a particular time, that is called cross-section data. For example, if you want to examine that, what is the socio-economic conditions of farmers in a particular village. So if you collect in this month, this is called cross-section data. For example, at a point of time, for example, tomorrow you are going to collect information. Tomorrow, nothing but at a point of time you are going to collect. That is a cross-section data. Okay, so that is called cross-section data. At a point of time, in a particular time, if you collect the data from the respondent, that is called cross-section data. So what is the time series? So if you collect information from the same persons, the same farmers from 2000 to 2020. So year by year, if you collect information from the farmers about their conditions, so that is called time series. That is called time series. In 2001, you have collected. In 2000, say, 2, you have collected. So from 2001 to 2020, if you collect information from the same respondent from the same village, that is called time series data. Time series data. So if you plot the diagram only, you will get that such kind of data. See, you will get such kind of plot graph. Whatever the data is there in time series. So whatever the data is there, for example, if you take into account year wise, you can take years. That's the time on x-axis. On y-axis, you need to take the variable value. Variable value. For example, here inflation rate. So, for example, in the particular year from 1975 to 2002, how much the inflation rate in US? So you will take this inflation rate on y-axis, years. There's a time on x-axis. You may take second wise, hour wise, weekly also, no problem. So on x-axis, you need to take the time, and y-axis, you need to take the variable values. So what you observe here, see, when you are taking some time series data, you can observe some trend, whether it's a positive trend or the negative trend, so it doesn't matter, but you can observe some trends. See, there is some ups and down. That is called fluctuations. That is called fluctuations in the time series data. So when there is some fluctuations in the time series in statistics, we will call that is called components. We will call that is components. Nothing but what are the variations? So why there is a variation? Why there is a ups and down? That is the main thing we need to study. That is called components of time series data or components of time series analysis or time series variations or time series variations. See, there is another flat, another graph also. You can see the crime rates. There are different types of crimes. So similarly, generally the police department will publish this kind of data about that how much crime is there, how much crime is rate is there in particular state or particular city, whether it is increasing or decreasing. Okay, so why there is a fluctuation, why there is an increasing, there is a decreasing, and why there is increases. So we need to study that what is the variations are there in time series analysis. Generally, that is policy. All I told you that when we observe time series data, there is some fluctuations due to number of forces. So we will call them components of time series. So as we discussed, secular trend, seasonal variations, cyclical variations. So we left the random variations. So one by one we will discuss briefly. So what is the secular trend? Secular trend, nothing but see there is a long-term trend. Nothing but when you take the more number of observation, you will get a smooth trend. Nothing but you will get an upward trend or downward trend. But you will get in the long term, you will get a smooth long term movement. Nothing but from the period starting to ending, there is in the middle you will get some fluctuations. But from the starting to ending, you will get some upward or downward trend. So this is see in the long run, it may increase or decrease over time, overall upward or downward movement. So if you observe this data, see if you observe from year to year, sales has been increased or decreases. From starting point to ending point, see here this is the starting point, this is the ending point. What you observe simply you can there is a smooth upward trend, nothing but there is an increasing trend when you observe in the long term. And the second one, see the trend may be upward or downward, and it can be linear or non-linear. For example, if the trend is very linear, nothing but if it is a straight line, that is called linear. If it is not a straight line, that is curvilinear. See, this is called curvilinear. This is called non-linear trend. Non-linear trend. So here also you can observe this first one and two are the linear trend. So this one is non-linear. This is not see. This is not a straight line. This is not a straight line. This is a curvilinear. And seasonal variation, the seasonal variations are occurred within the year, often monthly and quarterly. For example, if you take into account sales of ice cream, sales of cool drinks, or rainfall. Say in summer season, the sales may be increases after winter season. For example, if you take into winter season, there are some commodities which the sales will be high. After winter season, the sales will be come down. So these are summer seasons, summer and winter. The winter seasons, for example, if you take, it may be ice creams or cool drinks, for example, in summer season, in summer season. And the winter season, if you take into account woolen goods, woolen commodities. So there is ups and down in the seasonal variation. Nothing but that depends on the season, the sales will be high. So generally the seasonal variation occurs in natural forces. There is the weather conditions, climate conditions. For example, if you take in this season, winter season, see there is a good demand for that woolen goods, or there is a high sales of woolen goods in this particular season. After the season, the sales of woolen goods may be decreases. So, for example, if you take the season-wise customs and traditions, for example, if you take the festivals, so during the first particular period, the sales will be high of the particular commodities. For example, if you take the cloths, so there's a good demand for that when the festival of Dasara and Deepavali, some other festivals. For example, if you take Ramjan, so during the particular Ramjan, there is a good demand for the product cloths, and if you take into account Dasara, Deepavali, there is a good demand for that cloth. And there is cyclical variations also there. See, in cyclical variation, if you observe the macroeconomics, so we have the business cycle. So if you take generally the GDP, so if the starting point, for example, if you take into account our GDP is a particular place, so it will goes up to the peak level Then it comes to down, nothing but, so whatever it takes place from here to here, that is called boom. When it reaches highest place, that is called peak. So after peak peak level, so if the GDP will be fall down, that is called recession. The GDP value will be coming down, that is called recession. When it occurs at bottom level, that is called low level, that is called drought or depression. Generally, generally the economics people, they will call that a particular state or a country is in the depreciation. It means that depression. It means that there is a lowest value of GDP. Then after the lowest value of GDP, it will recover. So here it will recovers. This is the recover. Then it takes boom. Nothing but its growth rate is faster rate. Then it will reach the peak level. Then again peak level, it can fall down. This is called business cycle. Business cycle. So as I told you in the earlier class, there's a business cycle. So current that peak level, the peak level value is highest compared with its previous and its future. Plus one only. Then the random and irregular components or random variation or irregular variation, which can indicate with the R. Random and irregular variations are called residual fluctuation. Nothing but residual, nothing but the randomly which can happen in the economy, which do not repeat in the definite pattern. Nothing but whatever the situation can happen, which cannot repeat again and again. Nothing but in a particular period, it cannot repeat. That is called, see, for example, if you take earthquakes, earthquakes will happen every year or every month? For example, in this month, if earthquakes will happen, so next month it will be happen? No, doesn't matter. Nothing but it does not repeat again and again. That is called, these variations are purely random, erratic, unforeseen, and unpredictable. So easily we cannot predict. In the next month we will get earthquake. We cannot predict. This is called randomly it can happen. Randomly it can be happen. And this variation beyond the control of human hand. But whatever the variation will happen randomly, which the human beings cannot be controlled. Nothing but the whatever the random things which they are not controlled by human beings. For example, if you take stock prices, earthquakes, sudden rainfall also, the even IMD also, Indian Meteorological Department also cannot predict that. See, that's due to random variations of the nature. For example, floods, rains. For example, if you take normal rains or floods, earthquakes, and accidents. So when you are driving, so will you expect that we are going to get some accident? No, nothing but randomly it can be happen. Unusual events. Simply we can say unusual events. So this is called components of time series analysis. This is very important for you that sometimes they will ask that what is meant by time series and what are the components of time series analysis. See, on the basis of conclusion, see, the time series analysis is to discover that magnitude and direction. So what the time series can explain to us, they will show that magnitude and direction, how much change is there, and what is the direction of the trend. There is a positive or negative. And nature of effect of seasonal changes. So what is the nature and what are the effects of seasonal changes? Why the seasonal changes will happen? And suggest randomness movements. So there are the four components or the four variation, that is a secular trend, cyclical variation, seasonal variation, and random or irregular variation, TCSR or TSCR. So the time series are not necessarily mutually independent. So next one, we will come to know that methods of measurement of trend. So basically we came to know that what is the trend, whether positive trend or negative trend. But how we can estimate the trend, that is a very important. So there are some methods to measure the trend. So this is called methods of measurement of trends. So this is the main topic we will discuss today. See, there are time series component analysis, as we discussed that TCSR or TCSCI or I for irregular or R for random. Don't confuse. So earlier I mentioned the TSCR. So user primarily for forecasting. Why we can use the time series on the base of previous year data. So we will easily forecast it. For example, if you have the data of the tomato prices in this week, so tomorrow you can expect what is the price of the tomatoes when you have the data. And we can observe the values in the time series and some of the product of components. So here simply we can observe that when you are observed all the seasonal indices, that is all the variations clubbed together, that is called additive model. That is called xt, there is a x variable of in the particular time series t is equal tt, there is a secular trend plus seasonal trend plus cyclical trend plus irregular trend. So when we add these four variations in a particular variable, that is called additive model. Additive model, nothing but addition. And multiplicative model, nothing but see when you multiply all the variations together. Okay, so see here xt, particular variable in the time to say time is equal tt, there is a secular trend or trend variation into seasonal trend into cyclical trend into irregular trend or random trend. Okay, so when you multiply all these trends, that is called multiplicative model. That is called linear in log form. For example, we can say we can measure in the log form or uh, linear, nothing but for example, if you take linear model or linear in log form also. So this is not important for you because it is an advanced, so it is not much useful for you at the degree level. See here in our syllabus we have that methods of measurements. There are three only measures of measurements in our as per our syllabus: graphic method, semi-averages, and moving averages. So how we can measure the trend by graphic method. Also we can measure the trend whether it's a positive or negative, and by calculating the semi-average also we will come to know that. And when you are calculating the moving average also, you will come to know that what is the trend. So first we need to discuss that is the trend before before entering into these three. There's a graphic and semi-average, moving averages. First one is the trend. The study of trend may be useful in itself. So in the separation of deviation from the periodic movement. For example, whatever the data is there, so on the basis of the periodic movements, for example, if you take some periods, so there is some trend, there is a positive trend, there is a negative trend, there is some fluctuation over a period of time. You will find out the trend. Then it may be useful for comparison with past and present. So when you put some graph or when you find out some trend, you will easily observe that. So before what is the trend and after what is the trend. Before and that is called past and present. Past and present. So what is the past trend and what is the present trend? For example, if you are running a business, so if you want to know that what is the sales of your company. So for example, see earlier if you collect information about your sales of your company, you will come to know that what is the sales in the past and what is the present sales. And you can also forecast for the future sales, how much sales will be happen in the future. Particularly, it can be helpful in having the peep into the probable future also. See, as I told you that when you have some data time series, easily you can observe that what is the past trend, what is the present trend, what is the future trend. So generally the trend may be obtained by the following methods. So as I told you that graphic method and semi-average and moving average. See, there is a freehand drawing method. Simply whatever the data is there, if you draw some method drawing, there is a graphic presentation, you will get that is what is the trend. And if you calculate that method of semi-averages, if you find out the semi-averages, so easily you can find out the trend. What is the before and after, or in the middle also you will find out the trend. And third one, the method of moving averages, the method of moving averages. And fourth one, the method of mathematical functions, the method of mathematical functions. If you take this mathematical function, that is called, we can say that regression analysis by using the time series data. But in our syllabus, we don't have at the degree level the method of mathematical functions, and high and low midpoint also we don't have, but only we have the three only. So we will discuss three only. So if you want, then I will teach you that how we can calculate that trend by using the mathematical functions. How we can find out the trend by using mathematical functions. So today we'll discuss one by one this hand drawing method and semi-average and moving averages. See, there's the first one is a free and drawing method. What is a free and drawing method? Simply, whatever the data is there, if you take the data, then if you draw a graph, that is called free and drawing method. See, for example, I have taken the data, there is a year and production quintals. For example, 2015, and whatever the year is there, there's a time we should have to take on x-axis. There's a time 1, 2, 3. There's a 1 for 2015, 16 for 2, like this. So this is a production in terms of quintals. There's 15, 28. See here, I have taken that 0, 5, 10. So here the difference should be same. The interval should be same. See, in the 2015, how much the production is there? 1, 15. See here, the point is here. In the second year, 2016, what is the production? 28. See, 28 in the between 25 to 28, 30. In 2017, the 32. They both 33. And the fourth year, that is 2018, how much? 38. And the 2019, the production is 39. And 2020, the production is 40. So when you draw some graph, you can easily observe that whether there is a positive trend or negative trend. Anybody can say that? Hello? Durga Prasad, Sravani, Lavakumar.
Sir. Sir.
Have you got the point? Simple. When you have the data, simple you can plot a diagram. You can draw a diagram. Then you will come to know that what is the trend? Is a positive trend or downwards trend? Positive trend or negative trend? Durga Prasad, Sravani, and others.
Negative.
Here, from 15 to 40, it's a positive trend. See, it is a upward line, no?
Positive, sir.
Positive only. Okay. So this is the free and drawing method. This is very simply. Is it clear? Sravani, Durga Prasad, and others. Supraja, is it clear? Hello?
Sir, clear, sir.
Then the method of semi-averages. Second one, method of semi-averages. So in this method, the whole data can divide into the two equal parts. That is the semi-average. But whatever the data is there, you need to find out the two equal parts. That is the semi. For example, see, if you have the data from 1991 to 2016, how many years will be there? There are 26 years data. When you divide into two equal parts, there is a 13 years and 13 years. So we need to divide into two equal parts. There is a 1991 to 2003 and 2004 to 2016. That is 13 years. So another example, if you take as we have taken the year and production. See, there are 6 years, right? So the 6 years is here data. So when we are divided into the two equal parts, the 6 years can divide into two parts. This is 3 years and 3 years, right? See, these 3 years and these 3 years. Then after find out the 3 years, we should have to calculate the average. That is the mean. That is the sum of x by n. Sum of x is nothing but total value of these 3 divided by 3. That is called 15 plus 28 plus 32. How much you will get? 75. 75 by 3. That is called 25. Then we need to calculate the average of this semi values. See, 38 plus 39 plus 40. So which is equal to that 117 divided by 3. So you will get 39. So what should we conclude on the basis of this semi-average? So here in the first semi-average, the value is 25. In the second semi-average, 39. The average production is 39. So we should simply conclude that during the second period only, the second period nothing but from 2018 to 2020, the average production is very high compared with the 2016-17 average production. Am I right? Durga Prasad, Sravani, Lavakumar, and other?
Yes, sir, correct.
Then that method of moving average, see, for example, if you take So in this method, another method one is the method of moving average. Simple, you can take moving average. So in this method, we need to calculate the average of the with respect to time. With respect to time, moving. So time to time, we need to add the values, and we will calculate the averages. Generally, we will calculate the 3 years, 5 years, and 7 years moving average. So in our statistics, basically, most of the people will follow 3 and 5 years. Only less number of people will follow 7 years or 9 years moving average. When the data have, when they have the number of observations are nothing but when the time will be more. For example, sometimes they will ask question, find out the 3 years moving average for the following data. Same data we have taken from the beginning. See, find out the 3 years moving average for the following data. So see, this is a 3 years moving average. See, data is here year wise and data is here. So how we can calculate the moving average? I'm going to show. See, simple the formula 3 years moving average. The first average, there is x3 star is equal to x1 plus x2 plus x3 divided by 3. What is x1, x2, x3 here? This is the first one, 15, 28, 32 divided by 3. Then what is the second average? Then x2, x3, x4 divided by 3. Here x2 is nothing but 28 plus 32 plus 38. Then we should have to calculate 3 years. First three values we should have to average. Then we should have to left out this first one value, and we should consider this and this and this. 58, 32, 38. Then we have to calculate the average. So I will show you one by one. So like that we should follow, etc. For example, annual data. See, if you take this data or this is another data, year wise, year 1, 2, 3 up to 10. So sales in the first year, in second year 40, third year 25, like this. For example, see, as I told you that in the 3 years moving average, 15 plus 28 plus 32 divided by 3, 75 by 3, you will get 25. So where you will get, where you need to put 25. So the 25 we need to put exactly opposite to the mid value. Within the 3 years, what is the middle value is 15, 16, 17. What is the mid value? 16 only. So this is we need to write 25 opposite to the 2016. Right? Then will you calculate that is the 28, 32, 38? See, you can find out the average, moving average 28 plus 32 plus 38 divided by 3. How much you will get? 72.66. 72. Sorry, I have something wrong. 28 plus 32 plus 38 divided by 3. You will get 32.66. 32.66. 32.66. So when you are considering these three values, so you should have to write that is the average value quite opposite to the mid value, that is opposite to the 2017. Then after that, what should I have to take? 32 plus 38, 32 plus 38 plus 39. Then you should have to calculate 32 plus 38 plus 39. So divide by 3. So you will get 36.33. So here you should write 36.33. Then the next you should have to calculate 39, 38, 39, 40. So again you should calculate 38 plus 39 plus 40 divided by 3. So you will get 39. So after that, you cannot able to calculate the 3 years moving average. 3 years moving average. So because only we have the 2 values, we don't have the 3 values. Okay. So then you should have to here, you should have to left here, and here also you should have to left. Simply you can put dash. So these are the moving averages. These are the moving averages. Moving averages. Is it clear, Durga Prasad?
Yes, sir. Clear, sir.
So you can keep in mind how we can got the 32.6.
Yes, sir.
How we got 32.6? Can anybody can say that? See, 32 is nothing but 28 plus 32 plus 38.
38.
Okay, divide by 3.
3.
So is equal. So almost 28 plus 32, 60 plus 38 by 98 by 3. 98 by 3. So 98 by 3, you will get 32.6.
32.6.
Okay. So like this, we got these values. Okay. Now. So why we can do this method of moving average when there is a simple fill and drawing method? So we should compare that whether why we can do this moving average. See, the calculating a moving average, for example, if you take this is another one, you can take, see, the 5 years moving average. So earlier we calculated 3 years, now. So here 5 years. So this data, see, the 5 years, 23, 40, 25, 27, 32. These are 5 years, now. So after say these are 5 years sales. So we should have to all the values we should have to add and divide by 5 because we are consider 5 years moving average. So when you consider the 5 years moving average, so the 5 years moving average is 29.4. See how the 29.4 has come. 23 plus 40 here, see, plus 25 here, plus 27 plus 32 divided by 5. How much we got? 29.4. So what is the next 5 years average value? Anybody can say? Sir?
Sir, 40, 25,
25,
27,
27,
32,
and
48.
48. So you should have to add all these values, then divide by 5. Then you will get 34.4. Okay. So here we should have to put these values quite opposite to the mid value. For example, the first year, what should have to you have consider 5 years now. So we should have to put this 29.4 quite opposite to the 3 year because the 3 is a middle value, right? So when you calculate this 40, 25, 27, 32, 48, then we should have to put the 34.4 value quite opposite to the 4. There is a 4. Okay. Am I right?
Yes, sir.
See, for example, if you want to collect last one, see 33, 37, 37, 50, and 40. So you should get value 39.4. Then you should have to put this 39.4 quite opposite to the 9 because so from 7 to 11 the mid value is 9, right? Do you have any confusion?
Yes, sir.
Lavakumar, Shravani, and other people. Supraja. Is it clear? Is it clear? Hello?
Sir,
Is it clear, Amma? Ardhamaina?
sir, once again, will you explain, sir, please?
Hey, calculate the 5 years moving or nothing, but we should have to take 5 years. For example, say first year, see year wise sales, year 1, 2, 3, year wise. This is years, not numbers. See, year sales. In the first year, your company sales is 23. So in the second year, your company sales is 40. In third year, 25. Fourth year, 27. Fifth year, 32. So this 5 years, what is the average of the sales? That is called 5 years moving average. Simple. Here, we should have to add all these 5 values here like this 23 plus 40 plus 25 plus 27 plus 32. Then we should have to divide by 5. This is because 5 years moving average. then you will get 29.4. Whatever you will get that value, we will put against the mid value of the year. So in the 5 years, what is the mid value? 2003, for example, if you consider. So you should have to put, there is a 3, 15.4. Here you should have to write here. After next you can put a column here. Then you should write 29.4. Is it clear?
Okay, sir.
So next you can take 40, 25, 27, 32, 48 like this. Then you will divide by 5. Then you will get 34.4. Right? So if you compare the annual and moving averages, for example, this is the annual averages, blue lines. So when you find out the 5 years moving average, see here, these values, whatever you get 29.4, 34. Up to 39.4. See what you observe from annual data and moving average. So when you draw annual data, on the basis of annual data, if you draw the graph, so there is some fluctuations. See from year to year, ups and down. Am I right? When you observe the 5 years moving average, you cannot find out such kind of fluctuations. But there is some fluctuations, but there is a less fluctuation. It's a smooth curve. Nothing but there is no much fluctuations. See, that is the 5 years moving average smooths the data and shows the underlying trend. So we can come to know that there's a trend. There is a positive trend. So for example, if you see from 29 to 39, so we can easily observe that there is a positive trend, right? 29 to 39. There is a positive trend from year to year. Is it right?
Yes, sir.
Okay, thank you everyone for your patient listening.
Thank you, sir.
If you like this video, please share and subscribe to get more updates.